Thank you very much, Sarune, for kind introduction. Let me share my screen first. Can you see my screen?
Yeah, we can see. Okay.
Great, thank you. So what I'm going to talk today is the head-mount display system we have developed about 6 years ago, which can reproduce the visual hyper and hypersensitivity in autism spectrum disorders. As you know that the persons with ASD are often suffer from the hyper and hypersensitivity in visual, audio, tactile sensation, and so on. And we first look at what kind of the visual world their persons with ASD experiences, and then how their difficulties also causes the social communication difficulties. So let me start with the one video clip which introduces our head-mount display system. So you can see the lady who is wearing the to work to survive in their environment without any very specific stimuli. She often has the pain in her eyes caused by the environmental signals. The reason why we started investigating the atypical visual perception is ASD is that my colleagues working in the same universities investigating the autism spectrum disorders from the first-person perspective. This research field is called Tojisha Kenkyu in Japanese. In English, it corresponds to first-person study, which means that the researchers who have autism spectrum disorder by themselves investigate their perceptual world, action world, and also their cognitive processes from the first-person perspectives. This is their video clips showing how they discuss and share their daily experiences, and also they share how they cope with such difficulties in the daily life. And my colleagues in the University of Tokyo organizes this kind of meeting every month and then collected a lot of data. And then they have been analyzing this data, the qualitative data, using their phenomenological method. For example, in one meeting, they have discussed what their bodily feelings the persons with ASD often have, especially when they are alone. Sorry that there is a Japanese, you cannot understand the details, but from their left side figure, you can get their ideas, what they have discussed. For example, the one person said that their whole body perception suddenly disappears when she or he is alone. Or these illustrations, so you can see the border between the body and the environment. So another person said that she or he feels very strong their boundaries between their own body and the environment, which they prevent them from interacting with the world. They feel that their body is completely frozen and they cannot move at all. That's the perceptual and subjective feeling that persons with ASD often have. And another example says that the person with ASD, especially my colleague who has autism, says that she has difficulty in feeling hunger. Maybe you cannot imagine how difficult for them to feel in hunger, because we often just immediately feeling hunger when the lunchtime or dinner time is close. But according to her explanations, she first perceives a lot of different bodily sensations. Like, for example, her stomach starts moving, or her feel the chest discomfortable. Or she also feel that there are cold limbs or itchy scalp, which might not be relevant to their hunger feelings. According to her explanations, she adjusts the faces, these many different types of the sensory signal at the beginning, and she cannot make sense about this sensations, the sensory world first at the beginning. And then she has to very carefully think about what this feeling means, what these sensations mean. She has to carefully choose which information is relevant to the certain situation and which are not. And then only when she is successful, she can recognize the feeling of hunger. She said that she cannot even recognize the hungriness, especially when she is alone and she does not receive any environmental signal or the social signal. Sometimes the external signals helps her to organize, to structure her own feelings to make the sense of her body sensations. And then from these studies, we thought that although we know that the persons with ASD often suffer from the social communication, but their core problems exist not only at the social level, in the higher cognitive level, but also in the low level sensory motor control. Then we studied what visual world they have, and then why their visual world also causes the social difficulties. Here, I want to first emphasize the two main challenges in investigating the atypical perception in autism spectrum disorder. The first challenge is to assess the atypical visual perception in ASD, which is, of course, subjectively experienced. Not only case of ASD, but for everyone, the visual or any types of the perceptual experience is subjective experience. So we cannot directly measure their visual world. So the question is how we can assess such a subjective experiences. And second challenge is to quantify the social context. From their interview with the person with ASD, we recognize that different environmental situation causes different types of atypical perception. For example, the office, station, shop, outdoor, and so on. Many different social contexts seems to be associated with their atypical perception, and they causes different types of atypical perception. So the question is how we can quantify such a social context in order to understand their core causes for environmental causes for the atypical perception. And then to address the first question, we decided to introduce their computational approach. Myself, I'm working in the AI or robotics research field, so we know a lot of the visual, the perceptual, the filters we can design. So we decided to prepare several visual filters which can reproduce the atypical patterns in autism. For example, we prepared the dotted noise filter. You can see that many colorful dotted noises are floating in the air, or the highly contrasted filtered image. Or that we can also emphasize the intensity of the image or reduces the color from the image. Or also the blurriness and edge enhancement were the typical patterns of the atypical perceptions we found from their experiment where we interviewed with the participants. Actually, in the preliminary experiment, we prepared in total 12 filters, different filters, and then we asked ASD participants to tell which filters is more plausible or more, more often experienced by them. And then we finally selected these 6 filters for the experiment. And then using this filter, we asked participants with ASD to reconstruct their own perceptual experiences in past. We first asked them to watch the video clip, 20-second video clips, which shows that a certain social context. For example, in this case, the festival can be seen in the video clip. And then the participants are asked to choose one or not only one, but the filters which can reconstruct their visual world in the past. They can click them, and then they can also adjust the strength of their filters to see how their original image will be modified. And by they are designing this experiment and then conducting the same experiment in using the many different social contexts, we could obtain a lot of data. This illustrates what kind of data we can gain. For example, in case of the festival, we could observe For example, the dotted noises are selected by some participants, or more participants selected the highly contrasted filters, and so on. So the thickness of this line showing how many persons selected each filters and how strongly the filters are selected. And just by observing this, the result, the illustration, you can see some kind of correlations between their environmental signals and their atypical patterns of the visual perceptions. But this is not enough, not sufficient for the analysis and also for designing the head-mount display. Because, for example, that even if we say a station, there are many different types of station and many different sizes of the station. Big stations often have the loud noise, many people, lot of trains, whereas the small station have less trains, less people. So the stimulus existing in the station, two different stations, also quite different from each other. So the question is how we can quantify this social context. As you and a computer scientist, you can imagine that we can also obtain, extract their features, their quantitative features from each video clip. Here I show their 4 representative features we extracted from each video clip. For example, the brightness, of course, represent how light their image is. For example, in the case of snow scene, the brightness is the highest number. Here is 1.0. We can also extract the edge feature as a quantitative value, which represent how complex the image is. If many people or many objects exist in the scene, the edge feature shows the higher value. And we can also get the amplitude of motion and sound signals and so on. In total, we extracted 21 audiovisual features from each video clip. So once we extract their audiovisual features as a quantitative value, it's easy for us to analyze the correlation. Now we can apply the correlation analysis to see how their individual, so the visual audio signals correlate and also causes the atypical perception in ASD. I will show you the 3 main results we could obtain from our analysis. Here we can see the first basic information of experiments. As the participants, we recruited 22 adult participants who were diagnosed with ASD, and the age ranged from around 20 years old to 80 years old. And their AQ score was slightly higher than the threshold, so we could confirm that they have their ASD in also their daily life. And in our experiment, we prepared 29 video clips, which shows the social context, like in a station, school, shops, and so on. And then we prepared 6 types of filters, like a brightness filter, dot noise filter, and so on, that I showed in the beginning of my talk. And then the participants were asked to choose as many filters as possible to reproduce their atypical patterns. And then after collecting the data, we applied our correlation analysis to see the averaging patterns of their atypical perception. Of course, we know that their diversity, individual diversity is also an important features in the atypical perception. But this was our first trial, so we wanted to see first how they, as a group of the ASD, they have their similar or common their patterns of the atypical perception. So let me first show you the first experimental result, the analysis result, which was showed the strongest correlations between the environmental features and the atypical pattern. Our main finding, the first finding was that their brightness, their phenomena was often induced by the high contrast and the intensity, the audiovisual input. The left side shows the original video clip. On the right side, you can see the ASD's vision, which was reproduced by our correlation model. You can see that with the whiteout image, the people have difficulties in recognizing the object, or even they cannot see how many people are working there or what are in the images and so on. These patterns, these phenomena first observed very strongly and also almost from the all participants. This is also actually the result we expected in the beginning, because we already knew that the persons with ASD have larger pupil size. As you know, that pupil size control the amount of the light we obtain from the environment. So if you have the larger pupil size, you will obtain more stronger light from the environment. That's why you will get this kind of brighter images. And we also know from another study that there are latencies, and also the reduced the constriction, the amplitude in the pupil light reflex in ASD. So once you provide the very strong light to the person with ASD's eyes, usually the pupil will reduce, the size of the pupil reduced, but then this speed and also the amplitude of reduction is smaller and slower. So that's why the person with ASD often suffers from this too bright image, the visual world. So this is the first finding. What about the second finding? The second finding showing that the motion in the environment often causes the less color and the less acuity images. Again, you can see on the left, original image, and on the right, the ASDs, the visual world, which is again reproduced by our correlation model. If you carefully watch the video, you can see that the color are lost in the end of the video clip, especially if you focus on this green line on the train, you can see that this green line sometimes disappears and it gives the grayscale. So what is the cause for this atypical pattern? First, we did not know, we could not imagine why this kind of the colorless or the blurred images happens. But then by carefully looking at their physiological evidence and also anatomical evidence, we could come up with some hypothetical mechanism. First, from the anatomical study, we know that all persons have their different, can gain their different information depends on their retinal view, the retinal regions. We humans can receive only their very colorful and fine image only from the foveal region in our retina. And then in the peripheral view, we can gain only the blue word, no color, and the motion information. This is very common for everyone with anatomical evidences. But the difference seems to be that how strongly we rely on their foveal or peripheral information when we recognize the world. When we looked at their behavioral study and also the neuroscience study, we found out that the person with ASD often strongly rely on their peripheral vision. When the person with ASD watches the environment, they often use the peripheral vision instead of the foveal vision. And also their brain responses to the light, the stimuli, more strongly activated when they receive the peripheral visual stimuli than in the typical persons. This also suggests that persons with ASD have higher sensitivity in the peripheral view. And then from these two evidences, we think that the person with ASD have stronger reliance on the peripheral vision, and especially we know that the peripheral visions are sensitive to the motion signal. That's why the person with ASD often have the bluer and no color image when the strong motion is detected from the visual world. That is instead the hypothetical mechanism. And the third findings we could observe from our experiment is that the dotted noises induced by the change in the motion and sound. This is the same with snow, but besides snow, you can also dotted noises in the right side image. So these dotted noises are often observed when the motion and sound on the original image changed. For this evidences, for these findings, we cannot clearly understand why this happens. But down there, if we look at not the person with ASD, but the migraine patients, we learned that the migraine patients also observe the similar, the visual, the dot noises. They call it visual snow. And then the research also found out that the atypical brain activities like cortical spreading depressions in the visual cortex seems to be correlated with this visual snow. So in collaboration with the neuroscientist in the Osaka University, we started to investigate whether the person with ASD also had this kind of the atypical brain activities, which might be the potential causes for the dotted noises in ASD. So far we found there are 3 different types of the atypical patterns, but then we also still they're thinking what the brain activities or brain mechanism may cause this kind of atypical perception. One hypothesis is that according to the predictive coding hypothesis, which is recognized as a unified theory of the human brain, the person with ASD seems to follow the Bayesian inference when they integrate the incoming sensory signal and the top-down predictions. The key idea of predictive coding is that the brain perceives the word and act on the word in order to minimize the prediction error. And furthermore, it has been suggested that the process of integrating to incoming sensory signal and top-down predicted signals follows the Bayes theorem. And one research suggests that the person with ASD seems to have weaker plier prediction or hypoplier prediction, which might be a cause for the atypical hypersensitivity in ASD. So you see that the perception, which is a posterior in the Bayesian inference, is biased to the sensation of the word due to the hypoplier. And then they inspired by this theory, we have started the neural network, the modeling experiment, in order to see whether there are differences in the precision of plier predictions may affect their perceptual word and then motor word. So with that, this experiment is not about the visual, the hypersensitivity, but then we are also looking at the motor difficulties or motor atypicalities in ASD. And we observed that by modifying the precision of the the prior predictions causes the modification in the behavioral data. Here is an example. We trained the robot using this neural network to reproduce the many different types of representational drawing. And then by modifying the precision of prior predictions, we could observe that the immaturity in their behavior, which in some sense they're similar to the difficulties in the ASD, the children. And also that we found a very interesting study which utilizes the deep neural network to reproduces the hallucinations in their psychedelic. This is not different, a little bit different from their autism's atypical perception, but we think that there are imbalance between the top-down predictions and bottom-up sensation in the world, according to the hypothesis, might also causes the atypical hypersensitivity in ASD. So now we started to further investigate whether this theory can also explain the hypersensitive word of the ASD. And I also would like to share the last study, which we recently conducted using our head-mount display system. Here, our motivation is to reduce the stigma toward ASD by letting the person without ASD experiencing their ASD, the visual world. We designed their head-mount display system using our model, the correlation model, and then they ask their person, typical visual person without any hypersensitivity experience the ASD visual world. And then we measured their, using the questionnaire, their stigma toward ASD before the experience of this simulator and after. The important point of this workshop design is that we did not just ask the person's experience that is this word using the head-mount display, but also learn their scientific findings we obtained from experiments and also discuss and share their thought with other participants. This process plays a very important role to reduce the stigma. And we actually found that the reduction of stigma can be observed after experience the visual world, and which was sustained even after the 6 weeks later of this workshop. So we hope that we can utilize the head-mount display system not only for visualizing their ASD world, but also changing their society and also the stigma toward the ASD. This is the worst the trial we have done, and we hope that we can continue the studies of the simulators. And this is the very last slide. We found that the head-mount display, their design helped not only for the reduction of stigma, but also the the self-help for the person with ASD. This person is the lady who joined our experiment. You recognize that she wears the sunglasses. Importantly, she started wearing sunglasses only after joining our experiment. Although she recognized that she has their perceptual difficulties, but she did not know how they can cope with their visual perceptual atypicalities. Experiencing their head-mount display and also joining the experiment helps them to better understand her own perceptual world, her own cognitive difficulties. So we think that this kind of technology would help to the person with ASD, not only the person, the surrounding person, but also the person with ASD to better understand their disorders. So this is the summary slide, and this is just in summary what I talked. So I'd like to keep some their time for their discussion, and thank you very much for your attention.
Thanks so much, Yukie. It was really interesting. Quite a lot of relevance to what we do. So very interesting. I'll be looking up some of those papers for sure. Does anyone got any questions? I can see that Tammy had a question. Tammy, do you want to?
Yep. I noticed that you talked about the visual and auditory very briefly. I just wondered whether you found any link between auditory and visual at all, whether they affected each other or not.
Yeah, thank you very much. Very important questions. So, for example, in the findings, we thought that the auditory signal also affect the dotted noises. We found that not only the visual movement, but also the sound that affected there becomes the causes for dotted noises. So that, yeah, surely the visual and audio and even the sensory signals would affect the atypicalities.
So you think they're all intertwined then, all the senses? Oh, that makes a lot of sense, yeah. Thank you.
Thank you.
Appreciate it.
Okay, we've got Irene with a question next.
Yeah, thank you so much for your talk. It was really interesting. I was wondering whether you are thinking of doing something similar with children or maybe with participants with low functioning autism or something like that.
Yeah, we tried to design the children's study, but then their difficulties is that this experiment, the design is a little bit boring and also difficult because first the participants have to recall their past experiences. During the experiment, we suppose that the participants do not have the hypersensitivity in real time, but they just recall or remember what happens in past when they, for example, walking in the street or standing on the stations. So such a recurring process would be difficult for children to conduct. And then we also came up with an idea to design the more real-time experiment. I mean that using the smartphone they can start recording their visual world and then also directly adjust the filters in order to replicate their perceptual world in a real-time way. With this setting, I think that it's also possible to conduct the experiment with even with children, but then I think that some, I can say, high functioning participants would be the necessary in order to first understand what is the target of this experiment and collecting the data. Yes, the short answer is we tried, but we thought that it's a bit too difficult to really continue in that direction. So currently we don't yet have that data.
Thank you.
Thanks. I think, does anyone else? I think David had a question, had several questions.
Yes, thank you, Yukie. That was amazing. Really inspirational talk that you've given us there. I have several questions, so just stop me, Sharona, when somebody else wants to ask one. But I think that the first one is, so in your experiments, you use an adjustment method, right? So you present a video and then ask the participant to change the video to what it looks like for them, which I think is a really good approach. But have you sort of verified that process by doing something like a forced choice experiment where you present the actual video and then the sort of distorted video or a frame or something like that? So can the autistic participants tell the difference between the actual and the distorted video?
The way we used is that we used the same video in the beginning and the end of the experiment. And then we checked whether the participants chose the same filters for the scenarios in order to confirm that they don't randomly just choose their filters. That is one way we could utilize in our experiment. But still, it has the possibilities that they have not clearly understood what they should choose or how they should answer. This is the biggest challenges in collecting the subjective experiences.
Yes, of course. Yeah. Okay, I think I'll probably need to read the papers to get the full image of the design, but that's great. But a couple of other things. So the idea about, which I think is rather ingenious, the idea about pupil size being a big factor. Of course, in some of the research that we've done, we know that anxiety enhances sensory issues, especially hypersensitivity. And that would seem to fit really nicely with this pupil idea because, of course, pupil size is bigger when you're more anxious. So I just wondered if you clearly thought of that as well from the way you're nodding.
Yeah, we also recognize that their anxiety is a very important, plays an important role to induces the hypersensitivity. But in this experiment, we could not collect such biological data. Yeah. Because they asked their participants to just recall their past experiences in the experiment setting. But then we, of course, now thinking to utilize the more real-time their data collections using the smartphone and also some of the sensors to collect the physiological data like in the heartbeat and so on, and to see whether how their health condition would also affect their atypical patterns. Actually, there are some persons with ASD already told us that their health condition strongly affect their atypical perception. Some persons say that when they are sick, like have the fevers or cold, they have more stronger hypersensitivity. Or another person say that when they are, for example, concentrating on certain task, they have stronger perceptual hypersensitivity. So it has a very individual diversity in there.
Yes, of course. And I guess the final point for the moment is this idea of peripheral vision being enhanced in autism. I think also rings very true. And one aspect of that, of course, is the which you know, but I may be doing this for the benefit of others, is the sensitivity to flicker. So we know that there's this issue with fluorescent lighting, some types of lighting. And of course the peripheral vision is more sensitive to flicker as well as motion. So that would certainly fit with that story as well, that there's some sort of enhancement of peripheral vision at the expense of central vision. So I think that's a very, very nice idea.
Thank you very much.
Okay, that's me done for the moment. Sure.
Does anyone else have any questions? Everyone's feeling shy. I think we've had a few people that had to go to another meeting, but everyone seems to have enjoyed the talk, which is great.
Oh, I do have another point actually, Sharona.
Yeah, oh, you go.
I mean, I just want to really applaud Yukie for the idea of the participant having a better understanding of their own perceptual world. I think that's one of the goals of our research is to really work with the participant and in fact no longer call them a participant. This was a point brought up in the sessions yesterday, so that they really are co-researchers almost, and as part of that process of contributing to the research process, there's a greater understanding of how each individual's own perceptual systems work, and then they can implement whatever I'm not going to call it an intervention, but I mean whatever things, you know, like wearing glasses or something like that really works for them, so that they know that they've got new ways of dealing with their sensory issues when they become problematic. So
yeah,
I think that's a really good point.
Yeah, that is one of the strong point of our research. There are persons with ASD as a researchers strongly contribute, and also they help us design the experiment. Without their help, we also cannot come up with the ideas of their testing this study, they're conducting these studies. The co-productions is very, very important.
I think you're way ahead of us actually, Yukie. I think there's a lot of people trying to do research like this over here that
I know
are maybe not aware that you've been doing it for years.
I know that the UK is another very strong country who conduct their co-production study.
Yeah. I think we need to learn from your workshop ideas, because you have so many participants taking part and giving so much insight into the sort of inner world, if you like, of what's happening and what their sensations are. So yes, lots to think about, David, for our project as well.
Absolutely, yeah.
Any other questions or comments for you?
So I have a quick question, please, Yukie. I love that talk. That was brilliant. Thank you. So I was really interested, like David, in some of the pupil size findings that you presented. And I was also really interested in some of the Bayesian and active inference stuff you talked about. Have you looked at the relationship between some of these things as well? Because we know that anxiety is related to pupil size, but we also know that expectations about uncertainty and in different environmental states can also affect noradrenaline and some of these neuromodulators in the brain. Have you looked at the relationship between some of these things, and or are you going to look at some of this stuff in the future?
Yeah, that is actually our current ongoing project. We are strongly looking at the Bayesian inference ideas, and then we designed a neural network model, which can also replicate the Bayesian inference brain model. And then we are not so much focusing on the visual perception, but rather the sensory motor activities. And then using this kind of humanoid robot, we test how the precisions of prediction would affect their cognitive abilities. In this case, the drawing ability, for example. And then they also, in collaboration with their person who designed their network model, the hallucination machine, we also looking at how their imbalance between the top-down prediction and bottom-up sensation caused by the difference in the precision of prediction or sensation, which also causes the atypical the perception. This is an hallucination. It's not really observed in ASD, I think. It is more observed in the, sorry, I forgot, schizophrenia, for example. But we know that the schizophrenia and the autism have the stronger overlap in the perception and also the cognitive difficulties. So we think that this kind of a neural network approach, which replicate the brain, the predictive, the processing, which can answer to the question. Yeah, if you are very interested in this approach, we are also very happy to collaborate in this neural network study.
Yes, we're really interested in this, so I'll definitely be contacting you after this to see some of the work that you guys are doing.
Thank you.
Any other more questions for Yukie? No. Well, I think this is probably a good time to stop. Thanks again, Yukie, for such a good talk. There's just so much interesting findings you shared with us. So thank you again. One
Thank you.
To applause. Thank you very much.
Thank you.
So what we'll do next is I will pause the recording for
and pitfalls. My own background is in occupational therapy. My advanced degrees are in kinesiology, physiology, and biomedical engineering. So I have worked for many years, both clinically and in research, working on various different technologies. And about 20 years ago, I began to use virtual reality and virtual gaming. And that's what I'm going to address today with